Introduction to Six Sigma. The first chapter in our study material is Introduction to Six Sigma. Before we move on, it is important to get ourselves acquainted with this concept. Six Sigma is not a completely new way to manage an enterprise. It is simply a different way. In essence, Six Sigma forces change to occur in a systematic manner. Six Sigma started as a problem-solving approach to reduce variation in a product or a manufacturing environment. Variation implies that a process does not produce the same result every time. Please note that Six Sigma is not about quality in the traditional sense. Quality, defined traditionally as conformance to internal requirements, has little to do with Six Sigma. Six Sigma is about helping organizations make more money by improving customer value and efficiency. To link this objective of Six Sigma with quality, we'll need to look at a new definition of quality. For Six Sigma purposes, quality is defined as the value added by a productive endeavor. Have a look at how the process of Six Sigma works. Six Sigma begins by identifying the needs of the customer. These needs generally fall under the categories of timely delivery, competitive pricing, and zero-defect quality. The customer's needs are then internalized as performance metrics, e.g. cycle time, defect rate, etc. Target performance levels are established, and the company then seeks to perform around these targets with minimal variation. This slide talks about the basics of Six Sigma. This information will help you build the foundation of Six Sigma in terms of gaining basic knowledge about the concept. Let's discuss. Six Sigma is a highly disciplined process that focuses on developing and delivering near-perfect products and services consistently. It is a statistical concept that measures a process in terms of defects. The term sigma is used to designate the distribution about the average of any process. In statistics, sigma is the symbol that depicts standard deviation in the population. Six Sigma is a continuous improvement process. The reason why it is referred to as a continuous improvement process is because it provides businesses with a structured approach for analyzing their current performance and for determining how they can improve their processes to deliver their goals efficiently and effectively on an ongoing basis. Remember, efficiency is all about productivity, and effectiveness is all about the quality of your work. An integral ingredient of Six Sigma is a process-centric view. Before we move ahead, let's try to understand what is meant by a process. A process is a series of steps designed to produce a product or service as specified by the customer. A process-centric view simply means understanding the combination of the what and how inputs that come together to produce the final output. What needs to be remembered is that a product is the result of a process, and a process is the causal factor in producing a product. A lowercase sigma is the symbol for standard deviation. The standard deviation is a measure of how spread out numbers are. In other words, it is one of the measures of dispersion or variation. Six Sigma is a data-driven statistical methodology used to measure the quality of service and performance. Its methodology is based on established statistical process control (SPC) techniques, data analysis methods, and systematic training of all personnel involved in the activity or process targeted by the program. The term Six Sigma defines an optimum measurement of quality, 3.4 defects per million opportunities. In other words, 3.4 defects in 10 lack opportunities. An opportunity is a term used to imply the chance of committing an error. It signifies that the accuracy level Six Sigma seeks to achieve is 99.9997%. Let's put it this way. The DPMO of 3.4 equals 99.9997% accuracy. Now, let's talk about the salient features of Six Sigma in brief. Six Sigma is a rigorous and highly disciplined business improvement process adopted by companies to help focus on developing and delivering near-perfect products and services. Mikkel Harry, President and CEO of Six Sigma Academy, defines it as a business process that allows companies to drastically improve their bottom line by designing and monitoring everyday business activities in ways that minimize waste and resources while increasing customer satisfaction. The success of any Six Sigma project is based on team effort from top to bottom. It is very important that Six Sigma team leaders at all levels be cognizant of team dynamics. The Six Sigma approach to problem solving is completely data-driven and based on statistical tools. That is why it is said to be driven by logical reasoning. For the sake of refreshing our memories, it might help to reiterate that DMAIC stands for define, measure, analyze, improve, and control. It is the foundation of Six Sigma. The DMAIC is the classic problem-solving process. It resolves issues of defects or failures, deviation from a target, and excess input of cost or time. DMAIC addresses improvements in productivity, how many, financial, how much money, quality, how well, and time, how fast. PFQT. Similarly, the other two important business improvement methodologies under the umbrella of Six Sigma are DMADV, i.e., define, measure, analyze, design, and verify, and DFSS, i.e., design for Six Sigma. The difference between DMAIC, DMADV, and DFSS is that DMAIC is used to improve existing processes, whereas the other two methodologies are used to improve new processes. Y equals Fx. This equation represents the mechanism and approach of Six Sigma. It is a core Six Sigma formula. Typically, Y is referred to as the output, X as input, and the process that produces the output is referred to as Fx. It is read as Y is the function of single or multiple X's. At this stage, please remember that measuring X's and Y's is not an end in itself. X's have to be connected or related to Y's. Take a look at a few examples. If X is the cycle time, then Y might be on-time delivery. If X is the quality of work done, then Y might be the level of customer satisfaction. Take a look at the text in the rectangular box which says applies to any process. Six Sigma applies to any process irrespective of the industry, company, and/or domain you are associated with. Let us examine the nature of the Six Sigma approach or thinking. The DMAIC methodology of Six Sigma states that all processes can be defined, measured, analyzed, improved, and controlled. These terms represent the phases of the Six Sigma process. Collectively, it is referred to as DMAIC. Any process which has inputs, X, and delivers outputs, Y, comes under the purview of the Six Sigma approach. The Y equals Fx thinking methodology postulates that exercising control on input will accrue as control on output. This is the mechanism of Six Sigma, and as per this theory, every problematic situation has to be converted into this kind of equation before corrective measures can be implemented. The context of correlating X and Y to each other will vary from situation to situation. If X is your input, then only Y becomes your output. If X is your cause, Y will not be regarded as the output. If X is your input, Y cannot be called an effect. To proceed, the equation of Y equals Fx could involve several subordinate outputs, perhaps as leading indicators of the overall big Y. For example, if TAT was identified as the big Y, the improvement team may examine leading indicators such as cycle time and lead time as little y's. Each subordinate Y may flow down into its own Y equals Fx relationship, wherein some of the critical variables for one may also affect another little y. That other little variable could be your potential X or critical X. The Six Sigma approach begins by identifying the practical problem or the pain area which has been persisting on your production or shop floor. As per the Six Sigma approach, you will need to convert this practical problem into a statistical problem. When a problem is addressed with facts and data analysis methods, it becomes a statistical problem. The measurement and analysis of a statistical problem is completed in the measure and analyze phase of Six Sigma DMAIC. The statistical problem will then be converted into a statistical solution. It is a solution with known confidence or risk levels versus an I think solution. This solution is not based on gut feeling. It is completely data-driven. A Six Sigma DMAIC project will assist you to convert your practical problem into a statistical problem, and then your statistical problem into a statistical solution. The same project will also give you practical solutions that aren't complex or too difficult to implement. That's how the Six Sigma approach works. Look at the table to compare a 99% yield, less than 4 sigma, to a 6 sigma yield of nearly 100% quality. Then consider for a moment the potential lost profit in your company that is probably operating at 2 to 3 sigma. The message here is that Six Sigma forces organizations to pursue perfection by asking whether 99% acceptability is good enough. If it's really good, then the companies need to go through this table. Please note here that while Six Sigma corresponds to being 99.9997% defect-free, not all business processes need to attain this high of a goal. Companies can also use the Six Sigma methodology to identify which of their key business processes would benefit most from improvement and then focus their improvement efforts there. It clearly means that the Sigma level requirement for every process or vertical would always vary. Of course, areas for improvement will always exist because process improvement is an ongoing process. It is not a one-time activity. Your process or vertical owners will take a call as to what kind of Sigma level their process requires or what is actually good for their process. Six Sigma is a disciplined and data-driven approach. That is why decisions taken with the help of Six Sigma tools and techniques are based on facts, figures, and the relevant data. These decisions are never based on gut feeling or any personal opinion. Six Sigma methodology attacks high-hanging fruits. High-hanging fruits are the complex problems or hard stuff. Six Sigma addresses complex or critical pain areas first. It eliminates chronic problems in your process. Chronic implies a long duration or lasting for a long period. Once the chronic problem is eliminated, customer satisfaction is improved. The customer could be your internal or external customer, depending on the process you are engaged in. Six Sigma is an absolutely controlled approach to problem solving. Six Sigma is not a new way, but a different way to address and solve problems. As a result, it does help to change the work culture in an organization. And last but not the least, Six Sigma focuses on continual as well as continuous improvements. In a continual improvement, the team's improved processes, stabilized improved performance, and then improve again. Whereas in continuous improvement, the teams continue improving processes on a regular basis. For any process, this combination of improvements is crucial. The history of Six Sigma at Motorola can be summarized as follows. The term Six Sigma was coined by Bill Smith, an engineer with Motorola. Motorola is the company that invented Six Sigma. Late 1970s, Motorola started experimenting with problem solving through statistical analysis. 1987, Motorola officially launched its Six Sigma program. Motorola saved $17 billion from 1986 to 2004, reflecting hundreds of individual successes in the business areas like sales and marketing, customer service, transactional processes, product design. Dr. Michael J. Harry played a crucial role in formulating the DMAIC approach. The history of Six Sigma at GE can be summarized as follows. Jack Welch launched Six Sigma at GE in January 1996. GE saved $750 million by the end of 1998. GE cut invoice defects and disputes by 98%, speeding payment and creating better productivity. They also streamlined the contract review process, leading to a faster completion of deals and annual savings of $1 million. 1998-99, the Sigma Green Belt exam became the criteria for management promotions. 2002-03, the Six Sigma Green Belt certification became the criteria for management promotions. The milestones in the history of continuous improvement and their impact on other improvement models. Walter A. Schuhart worked at the Hawthorne plant of Western Electric, where he developed and used control charts. He is sometimes referred to as the father of statistical process control because he brought together the disciplines of statistics, engineering, and economics. W. Edwards Deming developed a list of 14 points in which he emphasized the need for change in management structure and attitude. He developed a plan, do, check, act model, which is also known as Deming's Wheel. Joseph M. Juran pursued a varied career in management, beginning in 1924 as an engineer. He developed the Juran Trilogy, consisting of 3 managerial processes: quality planning, quality control, and quality improvement. Deming and Juran worked in both the U.S. and Japan to help businesses understand the importance of continuous process improvement. Philip B. Crosby, who originated the zero defects concept, was an ASQ honorary member and past president. He has written 14 steps to quality improvement. Armand V. Feigenbaum originated the concept of total quality control. he lists 3 steps to quality: quality leadership, modern quality technology, organizational commitment. Kaoru Ishikawa developed the cause and effect diagram, which is also known as the Ishikawa and Fishbone diagram. He worked with Deming through the Union of Japanese Scientists and Engineers, JUSE. Junichi Taguchi taught that any departure from the nominal or target value for a characteristic represents a loss to society. He also popularized the use of fractional factorial experiments and stressed the concept of robustness. Quality Circles, 1979 to 1981, are quality improvement or self-improvement study groups composed of a small number of employees, 10 or fewer. Statistical Process Control, mid-1980s, the application of statistical techniques to control a process, also called the Statistical Quality Control. ISO 9000, 1987 to present, a set of international standards of quality system elements to be implemented to maintain an efficient quality system. Re-engineering, 1996 through 1997, a breakthrough approach involving the restructuring of an entire organization and its processes. Benchmarking, 1988 through 1996, an improvement process in which a company measures its performance against that of best-in-class companies, determines how those companies achieve their performance levels, and uses the information to improve its own performance. Balanced Scorecard, 1990s through present, a management concept that helps managers at all levels monitor results in their key areas. Baldrige Award Criteria, 1987 through present, an award established by the U.S. Congress in 1987 to raise awareness of quality management and recognize U.S. companies that have successfully implemented quality management systems. Six Sigma, 1995 through present, as described in previous slides. Lean Manufacturing, 2000 to present, focuses on reduction of wastage and improvement of value-added services. Lean Six Sigma, 2002 through present. This approach combines the individual concepts of Lean and Six Sigma and recognizes that both are necessary to effectively drive sustained improvement. Six Sigma started with manufacturing industries like automotive, consumer products, shipbuilding, etc. Its methodology was adopted by process industries such as pharmaceuticals, food production, pulp and paper, etc. Currently, we are in the age of the service industry, and Six Sigma has been beneficially adopted by the service industry along with lean tools. A wide range of companies have found out that when the Six Sigma philosophy is fully embraced, the enterprise thrives. Six Sigma is a fact-based, data-driven philosophy of improvement that values defect prevention over defect detection. It drives customer satisfaction and bottom-line results by reducing variation and waste, thereby promoting a competitive advantage. It implies wherever variation and waste exist, and every employee should be involved. The summary section will give you a glimpse of what we discussed throughout the presentation. Six Sigma is about creating a culture that demands perfection and that gives employees the tools to enable them to pinpoint performance gaps and make the necessary improvements. Six Sigma does make use of the full range of statistical tools that are available for analyzing and solving problems. The primary objective of Six Sigma is to reduce variability, Variability is the ally of defects. Hence, as the variation reduces, the number of defects also comes down.